Good morning. Now, this is in continuation with the previous discussion where we started orthogonality principles on signals. This session is in continuation with that one. Okay, let us start. Now, in the previous session, just we started the first principle of orthogonality principles. Now, what is the second principle? You take second principle, one sine harmonic and one cosine harmonic with same frequency harmonic, one sine harmonic and one cosine harmonic with the same frequency and or amplitude, not amplitude, and or phase value are always orthogonal. Always orthogonal. Now just look at, very important. One sine signal and one cosine signal with the same frequency and or phase value are always orthogonal. That means what? One sine signal may be given and one cosine signal may be given. They should have the same frequency. The phase value may not be equal. In those cases also, these two are orthogonal if you apply the orthogonality principle. For example, just look at, let us consider a signal x1 of t equal to 2 sine 3 n omega naught t plus phase value pi by 7. The second signal, that is equal to 5 cosine cos 4 3 omega naught n. Now cos 3 omega naught nt plus pi by 9. Now just look at, this is one sine signal, another cosine signal. Both are having the same frequency. The phase value may be same, may not be same. So here for x1 of t signal, frequency equal to 3 omega naught nt, phase value equal to pi by 7. For the second signal x2 of t, the frequency that is equal to 3 omega naught nt, but phase value that equal to pi by 9. So here important condition, the frequency of x1 of t and x2 of t are same. There is no strict rule upon the phase value. Therefore, these two should be orthogonal. Therefore, these two harmonics or signals should be orthogonal. These two harmonics should be orthogonal. That means what? Integral over the given period t1, t2, and multiplying these two. 2 into 5, 10 times, 10 constant. I am writing out of the integral constant of sine 3 omega naught nt plus pi by 7 into cos 3 omega naught nt plus pi by 9 of dt should be 0. Now just look at, this is the one sine harmonic and one cosine harmonic with the same frequency and or phase value. There is no need to depend upon this parameter. May be equal, may not be equal, but these should be equal. In the previous case, two harmonics with different frequencies and different phase values. They are orthogonal. Here, in this case, these two are orthogonal. This is the second property. Now, let us go for third property. What is the third property? A DC component and a sine harmonic are always orthogonal. They are always orthogonal. For example, just look at a DC component. What is the DC component? DC component is a numeric value, for example 5. Now here just look at, we are writing signals, for example x1 of t, that is equal to 2 times sine 2 omega naught nt plus pi by 19. If you write like this, this is signal representation. Now this can be called as DC component in electrical engineering. This is amplitude when you represent in the graph representation. The same thing, just you are calling it as amplitude. In electrical, we calling it as a DC component. These two are same numeric values. Here sinusoidal. This is called what? Sinusoidal signal. This is called frequency. This part is called frequency. This part is called phase value. This part is phase value. Analyze any signal like this. Now a DC component is given and a sine harmonic, for example 3 times sine of 2 omega naught n t plus, for example, pi by 5, any given. Here DC component and this signal, these two are over a time period t1, t2, or a time period they may given like that 0 t like that, anything, or minus t by 2 to t by 2, anything given. These two are orthogonal. This implies over the time period t1, t2, multiply these two, 5 times into 3 times sine 2 omega naught n t plus pi by 5 dt equal to 0. Now it can be written as 5 into 3, 15, constant. So 15 times t1, t2 of sine 2 omega naught n t plus pi by 5 dt equal to 0. So in every situation we have to make one important formula, t equal to 2 pi by omega naught, or omega naught is equal to 2 pi by t, where t is called fundamental period, omega naught is called fundamental frequency. These two should be applied wherever the letter W naught representation is there, where you can use it is equal to 2 pi by t, where t is called fundamental period. So this is the third property. Now let us discuss the fourth property. What is the fourth property? Energy and power. Look at, signals are said to be energy signal or power signal. Look at, signals can be, now here you can write signals. Signals can be either energy signals, or power signal. Now how can we differentiate energy signal and power signal? Now just look at, you make it energy signal, you can differentiate between power signal. Now just look at, in energy signal, energy signal, energy is less than infinity and power equal to 0. Average power equal to 0. 0 means what? You can make it finite. Okay, power. So now in power, so here you can make it another way of discussing this one. Now just look at, you can make it another way. So now just, what is energy signal and what is power signal? energy signal and what is power signal. Now, these two are very much important. First, a signal is called energy signal if energy is less than infinity. Less than infinity. Now, here the power is finite. Finite. In power signal, energy is infinite. Energy is infinite. So here power is finite. So this is finite. Here you can make it 0. Power equal to 0. Power equal to 0. Now, this is very much important. Just look at. A signal is said to be energy signal if the signal has its energy is less than infinity, but power is 0. A signal is said to be power signal if energy is infinity and power is finite. This matrix is very important between energy and signal. Again, I am telling the differentiation between energy and signal, energy and power signals. A signal is said to be energy signal if its energy is less than infinity. That means finite energy. So less than infinity means here you can make it as finite. If it has finite energy and 0 power. A signal is said to be a power signal if energy is infinite and power is finite. One more point, all periodic signals are periodic signals are power signals. All periodic signals are power signals. All periodic signals are power signals. That means what? Sine, cosine, all periodic signals are power signals. A signal is energy signal if it is if it contains other than these periodic signals. So it is energy signal or power signal. How to calculate energy? How to calculate energy? Equal to limit t tends to infinity integral minus t by 2 to t by 2 of the given signal whole square of dt. This is the energy. This is the way of finding energy of any signal. So first one, you have to find the square of the signal and you have to integrate between the given time interval, make it t to infinity. From this one, energy, you can calculate average power. Average power means what? Average. That means what? Write the energy formula as it is, infinity, between minus t by 2 to t by 2 and square the given signal and integrate with respect to dt and divide by its width, time period. This is average power formula. So no need to have any confusion. First you find the energy. This is the formula, limit t tends to infinity between the time period minus t by 2 to t by 2, squaring the given signal with respect to t only. With respect to 2 only. This is average power. Okay? So this ends the session. Thank you.